Okay, so let's go through these problems here. So I think that's enough time for everyone to give them a go. Okay, so remember these were the homework problems. So again, when you do go home, please try them again. See if you get the same answer. If you find anything too difficult, make a note and then come see me tomorrow or Wednesday. Okay, but please do not fall behind with this first chapter. Okay, so let's go through number one. This was the integral cos 2x dx. Okay, so same thing as we did for those other cases. We look at the outside function, we got an inside function. So the outside function is cos of something. The inside is 2x. So we let u be 2x. Okay, we've got u as 2x, now we need du. Du will be 2 dx. We don't want 2 dx, we want dx. So we need to divide by 2. Okay, that's as much work as we need. We don't need to do anything more than that. So we can substitute. Cos 2x will now become cos of u. The dx will now become 1/2 du. We can put that all together and write it as 1/2 integral cos u du. The integral of cos will be sine. Why? Because the derivative of sine is cos. You can always go back and forth like that. So this is going to be 1/2 sine of u plus c. We don't want this in terms of u, we want this in terms of x. So we can put the 2x back. So this will become 1/2 sine 2x plus c. Leave it like that, right? You don't need to use any trig identities, you don't need to simplify. This is perfectly fine as is. Okay, next one. Okay, like always, if you're stuck with anything is a problem for you, please just shout out. I can repeat or explain differently. Okay, next one. This was the integral x squared root 1 plus x cubed dx. Okay, very similar to what we had before. Forget the x squared, we can deal with that later. We've got an outside function, we've got an inside function. Let u be the inside function. So let u be equal to 1 plus x cubed. Okay, we can do this next part in our head. The derivative will be 3x squared. Okay, at this point your derivative should be very quick to do. Okay, now we've got x squared at the beginning there. Here we've got 3x squared. We don't want the 3. Divide both sides by 3. Okay, so that takes care of the x squared dx, and the u part takes care of the inside of the root. So we can substitute. So we get 1/3 integral root u du. Okay, the 1/3 comes from the du. We took that out. The root of the stuff inside just becomes root u. Okay, now we should write this as an exponent. So that will be u to the 1/2 du. 1/3 times. Add 1 to the exponent, it becomes 3/2. Divide by that, it becomes 2/3. Plus c. Okay, 1/3 and 2/3, we can multiply that. That will be 2/9. Okay, and then finally, we've got a u there. We don't want that. We replace it with the, let's see here, what did we have? 1 plus x cubed. So we just replace. We don't simplify, we don't try to do anything like that. We just put that in. Okay, Again, even if it looks like we can simplify, rather just leave it like that. Okay, that was number 2. Let's look at number 3. Okay, so this was the integral sine squared x cos x dx. Okay, in a couple of weeks, we're going to be looking at something called trig integrals. So integrals with only trig functions like this. This looks like a trig integral. We can do it like a trig integral. But remember what I said. Your first technique should be u-substitution. So we try that here. Now sine squared cos x, it doesn't look like we have an inside function or outside function. But remember, sine squared written like that is just shorthand for that composition. So we can write this as integral sine x alone squared cos x dx. Now maybe that looks a bit more obvious. We've got an outside function, something squared, and an inside function, sine. It's exactly the same as sine squared as we've written there, but maybe it's a bit more obvious for you. So let u be the inside function. Okay, now we need du. Derivative of sine, that's going to be cosine. And don't forget your dx over there. So when you're finding your du, remember to put your dx at the end, because that dx is part of your integral when we do that replacement. So this becomes the integral sine squared, that's going to be u squared, cos x dx, that's going to be du. Okay, plus 1 to the exponent makes it 3. Divide, we get 1/3. Sorry, plus c. Okay, so here we get 1/3. And we can keep the brackets like that. What was u? U was sine, so we can put sine. Sorry, sine of x cubed plus c. Okay. So don't take the cube inside, don't do any trig identities or anything like that. If I do say simplify, okay, then you can simplify, but that's fine as is. Or if you find it easier to write it like this, that's fine as well. But that's exactly the same thing. Okay, that's just your preference if you want to write it like that. Okay, next one, number 4. So here we have the integral. I'm just going to rewrite it a bit. So we have 1 plus cos x sine x dx. Okay, again, just ignore the sine part. Why? Because for the roots, we've got an outside function and an inside function. That's what we should be looking at first. Okay, so we let u be the inside function. Okay, du. Now here again, please do not mix up derivatives and integrals, especially with this sign. The derivative of cosine will be negative sign, minus sign. Okay, especially with this one here, because on the right there we've got sine. Here we've got minus sign, so we need to put the minus on the other side there. If you made a mistake and just wrote sine, you wouldn't have that minus sign carrying through. Okay, that makes more problems later on. So here it's in fact minus du is sine x dx. Okay, I'll show you now. That minus carries on later. If you don't have the minus there, it causes some more problems down the line. Okay, so this becomes the integral. Roots 1 plus cos x, that just becomes root u. Okay, and then the minus du. Okay, so now we have this minus sign out in front. Okay, so that's minus u to the 1/2. Add 1 to the exponent, becomes 3 over 2. Divide by that, that becomes 2 over 3. And don't forget your plus c. So now this becomes minus again, so it has to carry through. U, that is 1 plus cos x. 3 over 2 plus c. Again, you don't need to simplify that unless it's actually stated, right? It's always easier to leave it like this. Yeah, and we see that minus sign at the top, they're carrying all the way through there. So if you leave out the minus there, you're going to have a problem with your final answer here. Okay, any questions on this one? Okay, so very similar to all those other ones. Okay, and then the last one for today, we have the integral x root x plus 2 dx. Okay, so here this was similar to the last question we had before this. Oh, sorry, get that back.